Hi guys, my name is Kevin, and today I'm going to go through some questions related to probability theory and lattice models. So let's just get right into it. So for the first question, we are asked whether the inequality EX squared is more than mu squared is correct. Then we can just prove it directly because EX squared is normally associated with the variance of X. So let's write down the formula of variance of X. Is always equals to e to the power of x squared minus mu squared. Okay. Then variance is always greater than or equals to 0. Then we just substitute in the equation minus mu squared. Then e x squared more than mu squared. Okay, so it is now proven. Easy, right? For first question. So let's move on to the second question. Okay, so for the second question, right, we're asked the mean, mode, and median of the random variable x with the following distribution. First is standard normal distribution, and second is normal distribution with mean, mu, and variance sigma squared. So basically, right, this is the mean or mu, right? And this is the variance or sigma squared. This is the same thing. This is just the general equation. So standard normal distribution is basically just a special case of normal distribution with mean 0 and variance of 1. So we can directly solve this question, right? So question number A. So let's draw the PDF of the standard normal distribution. So, okay. So this is the PDF. So this is always mu, right, in the middle. And then what is the mu here? Mu is 0, which is also the mean, right? Then for the mode, we can just see the top here, which is the number with the highest frequency, which is also 0. Mode 0. And then for the median, it's basically just the CDF or cumulative density function of the mu. So as for median, is the CDF. This is the CDF logo of mu. And then mu is 0 in this case. So CDF is basically just the area under the PDF graph. So it means half of the area. So the total area of the PDF curve is 1. So half of the PDF curve would be, yep, correct, 0.5. So these are all the answers for part A. Whereas for part B, right, it's just the general function for normal distribution. So again, let's draw the PDF. But currently, the mu is just mu, right? So what is the mean? Mean is now still mu, right? As for the mode is also high up here, right, in the middle, which is also mu. And as for the median, it is always the same for normal distribution. Just the CDF of mu, half of the curve. The total area under the curve is 1, then half of the curve would be 0.5 as well. Yep, so this is the answer for part B for number 2. Okay, so for question number 3. Okay, so let's move on to question number 3. So for question number 3, we are asked to show that the mean and variance of this distribution is given by mu and sigma squared, respectively, by taking the first and second order derivative of mgf, which is this equation here, and setting the theta as 0. So we need to remember that mu, what is mu again? Mu is the first derivation of x, right? Which is the first moment of x. Then for variance is second moment of x minus first moment of x squared. Or this we can also say that this is also mx theta xn. And this is mx xn minus m. Okay, so this should be clear. Okay, so now we just move on to take the first and second derivative of the mgf. So the first, so let's rewrite the MGF equation, which is the exponential power of. Okay, then first derivative with respect to theta is mu plus half sigma squared times 2 theta. So just cross this. So it's just left with sigma squared theta e mu squared. Okay. Now, please remember that the theta is actually 0. Right? So you just mu plus sigma squared 0 e mu 0, right? Plus half sigma squared 0 squared. So this is basically 0, right? This whole thing is 1. So it's just mu. Alright? So we have proven that the first order of MGF is, which is the mean, is mu. Proven. Okay, now let's take the second derivative of the MGF. We need to reuse the equation over here, okay? This equation. Alright? Okay, so let's do it. Let's use our A-level formula, which is U V accent plus V U accent for this derivation. So U refers to the first term here. U is this one, U, and then V is this one, okay? So U, mu plus sigma squared theta, right? V accent means the derivation of the V itself. So it is mu plus half sigma squared 2 theta, right? Times E mu theta plus half theta sigma squared theta squared. Okay, then plus V. V is E mu theta plus half sigma squared theta squared times U accent. U accent means the first derivation of the U. So now it is left with sigma squared only, right? Okay, so now remember that the theta is 0. So for this one is 0, 0. This whole thing is 1. Then this whole thing is also 1. So now we are left with mu squared plus sigma squared, right? So this is the second derivative of the MGF. But we're not done yet, right? Because the variance is of x is what we wrote here just now. So it is mx. So the second derivative of the MGF minus the first derivative of the MGF squared, right? Mu squared plus sigma squared minus mu squared, right? So we get sigma squared. So now we have proven that the variance is sigma squared. So that's all for question number 3.